Welcome, ladies and gentlemen. I got mail, and I got it from that guy here. He's called Marco Reps, and he has his own YouTube channel which is running under the same name. And I lately sent him a little box of laser stuff, and as a thank you he sent me back this box here with some surprise stuff in it. So let's see. There is nothing, there is something. There is a schematic diagram for a JBC C245. That's a soldering iron, but at the moment I'm not sure what this schematic here really means. So let's have a look inside and let's see what Marco sent me. Okay then, I must admit I have already opened the package because that was inside the package, and here was the address label. You don't need to see that. But I'm pretty sure I haven't seen all yet because there is so much stuff in it. And I just grabbed a little bit around and let's see. Here we have moisture sensitive devices. No, I don't think that's the original bag. So it's that board here, which has a little display here. Some high frequency outputs. Output A minus and A plus. Okay. What's that? Mux out. Okay. Reset, USB, power. Well, I can tell you, I know what it is. It's a, what is it? Well, it's a, what? Point sweep hopping frequency. Okay, it's a frequency generator. Goes from 35 megahertz to 4.4 gigahertz with the sweep step of 10 kilohertz, so you can sweep the entire band up and down. And I probably can use that to test my 18 gigahertz frequency counter, which is functioning right now. Of course, only to 4.4 gigahertz, but that's already not too bad. Okay, what else do we have? So, something heavy that falls out. Okay, that looks like lasers. I know what that is. It's an RGB laser. Don't know which is which. Oh, okay, that is blue, red, green. 2 mirrors, and at the end, when all 3 lasers are on, you get a white laser beam, or a purple laser beam, or a cyan laser beam, or whatever. Okay, RGB laser. And this little gimmick here is the driver board for the RGB laser. You can see it here, RGB, and that's, I don't know, some else. Oh, fan. You can attach a fan to that. I have played a little bit with that laser, and it needs 12 volt on this wire, and with the 3 wires here, or wire pairs, you can switch on or off the individual lasers, red, green and blue. Okay, nice. We have to play with that. Then we have some nice aluminium labels in almost every language you need. English? Yes, here. Okay, German, French. That seems Italian and Spanish. Yeah, probably. seems to come from some industrial gear. By the way, Marco loves to play with lasers and CNC machines, so if you want to visit his channel. Okay, what's that? Probes. Very sharp tipped probes. They even have a protection around the tip. Yes, that feels pretty sharp. It also feels not too bad. It doesn't seem they are cheap Chinese models. ProbeMaster. Doesn't tell me a lot, so I have to Google that. Well, overall, I wouldn't say they are too expensive, but on the other hand, they make a rather good impression. Nice soft silicon cables. Yeah, I can probably use them because the original cables I have here from my Rigol multimeter, they are not as sharp here. They also have a screw. It seems the screw has a different thread. Okay, that looks like an American thread. That looks like a matrix. Yeah, I have to find out where that comes from. We have some probe accessories. Okay, some insulation tips. And we have that thing. And I would say that's from a telephone. Probably a speaker or a microphone. Don't know what it is. Certainly a German product, probably. 65, could that be the year of manufacturing? Ah, there, TN. I think that's something. Okay, so telephone speaker. I hope Marco is watching my video and he will laughing his ass off when I'm trying to find out. Oh, current sensor made in Switzerland. Welcome back home. A current sensor. So that's basically a device that has two large, you know what? Let us look inside. It's still originally sealed, or has been. Okay. Yes, it also works with gravity. I hope that doesn't break when it falls down. No, I don't think so. Okay, it's not the configuration that I usually know. So we have three very thick connectors here. So that's probably, they are all three in parallel. So that is where the current goes through. And here is the measurement port. So that means for every amp that you pass through, you get some milliamps or millivolts on this side. We have to look into the data sheet to be sure how it works. So what's that one? Okay, some kind of industrial camera from IDS. That means integrated display system, something like that. German company, made in Germany. Yeah, has a lens, has NA, not applicable. Okay, plus minus. Feels a little bit broken. We can unscrew that. So we have a relatively small CCD sensor inside here. And we have a lens where we can see through if I hold it right. Okay, maybe it's easier to do that. Oh, okay, that's the, how it is called in English. The shutter? No. The iris, okay, yes. Iris control. So you set that, and of course there is a lock screw because that really moves easily. Okay. Camera, sorry, has something that looks like an Ethernet, and I know I have looked in the datasheet, it is gigabit Ethernet. And it also has a connector for DC voltage. I tested it if it's probably power over Ethernet capable, but it is not. Or it is broken, so, well, there are also some screws missing, so, and these wires are also not original. I think someone has tried to power it up, plus, minus. Okay, probably not so easy to use because, well, Ethernet interface, I don't think you can give that camera an IP address, so it's probably not talking Ethernet, Internet protocol. It certainly has a MAC address, but you probably need some specialized software to use that. Okay, what is this? Standard profile bracket? I don't think so. That's just another bag with something inside. Looks like a kit. Unisolder. Okay. Some solder controller, soldering iron controller. We have sensor controller holder. I first thought this is some kind of modem, but Sparkysoft, one of these crowd-funded devices, 24 volt DC, 24 volt AC. So I think that's the input from a transformer. We have all the circuitry to manage a soldering iron, and then we have a bunch of cables to connect. That certainly goes here, hopefully. That's probably where this soldering iron is connected. That's a typical connector for these things. We have a large, well, I think best is I will go to search documentation about that. Okay, a soldering iron controller. Then we have, drill bits. That's nice. Made in China, and I think this time that could be probably the original package. Maybe, maybe not. And some DNA, thank you. Drill bits. Is it drill bits or is it milling bits? It looks more like milling than drilling. Okay, focus your fuck. I'm sorry, I'm not the right guy to say that. Yeah, I think that's milling bits. At least that one. That one looks more, well, it's difficult to say. It's an unusual geometry here. So the tip is very flat. Well, could also be drilled. Come on. Yes. Okay. Okay. one thing more to Google. And here we have super tiny bits. Okay, nice. I can certainly use them for this or that. Okay, what else? That looks extremely interesting. It's some rigid coaxial cable, or well, it's more like tube than cable. What could that be? And where could it be from? We have wires, stiff wires, some special insulation hard wires. Okay, you should never bend these rigid cables because all the pixies will fly out. We have a terminator from DC to 18 gigahertz. Yes, that's nice. 5 watts. So that's basically a resistor that is made to be linear on all the frequencies from DC to 18 gigahertz. Okay, yes, it's a relay. They call it a what? A high frequency switch, but with wires to control, so it's a relay. And it also has a frequency range of DC to 18 gigahertz. Fits perfectly to that terminating resistor or attenuation resistor. Okay, let's go ahead, and we have high voltage LED boost controller from Linear Technology. Yes, in its original bag. So that's a demo, a sample from Linear Technology. Sometimes you can order demo boards or samples from manufacturers and you get them for no money, for free. In this case we have an LED boost controller, high voltage. What does that mean? 25 volts. Okay, that's pretty high for an LED. So input is 3 volt to 14.4 volts. So I think it's made for, you could use it in your car with a 12 volt power grid or a 12 volt battery, whatever. Okay, and it has LED plus, minus, ground. Plus, minus and ground. Okay, why not? A run pin that must be tied high or low to make it run, and we have the inputs. Yeah, LED driver. A bag with small parts in it. I see 3 boards. Okay, that's it. Thank you. Okay. We have a banana ruler which measures 1 inch, half an inch, quarter inch. And we have a logo. Has it something to do with a banana pie controller? Micro? I don't know. Looks like it is made to hook on your keychain, on your key ring. And besides of that, I don't see much practical value in this thing. Okay, a banana ruler, why not? Then we have that board. It says OLED 1 here, so that's for an OLED display, obviously. And yes, some board to build something with an OLED display. Maybe it's just an OLED display driver board because we have an inductor here. that converts. Let me change the light a little bit. So you can build up an DC converter here, probably for that OLED display. Then we have that, which is USB to RS485. So RS485 is a serial protocol, so it's basically an USB to serial converter, which some features and jumpers here. Maybe I have to Google that also. Then a box full of goodies. What is that? Looks like a laser module. No. It has a coaxial connector, an electrical connector, not an optical one. Oh, someone has also opened it. Okay, that's interesting. That's one of these. What's that? Looks a little bit like a carbon rod, or maybe steel, I don't know. Maybe magnetic properties are important. It goes exactly over this part here. So that's one of these high frequency voodoo devices. I'm always fascinated with this high frequency stuff because I don't fully understand it. And it's more like mechanics than electronics, because everything is important, every band of, we can open that. What is that? This looks like relays again. Really? Really relays? Oh, a lot of gold inside. That's a beautiful device. Yeah, it looks like an electromechanical thing here. 1, 2, 3. Maybe that could be some sort of attenuator. So you're switching different values of to I don't know. Yeah, here probably switching this. Maybe there is some part missing. I don't know. I don't think that these contacts here go to that aluminium block, because gold and then aluminium, that doesn't make much sense. Interesting. Nice looking. Is there any part number on it? No part number. Well, difficult to find out. Maybe Marco has to help me with that. That's from the probes. Here we have 3 round things that are certainly not that part number, because that means trimming resistors. No, that doesn't look like trimmer resistors. What is it? Circuit. So I have already looked a little bit at them. On my first idea was it's some RFID tag, but why is there an open circuit? That doesn't make sense. And then if you look closely, you can see around this circumference, is that the right word? Something like LEDs here. Something that illuminates. So my guess is this is some sort of sensor button. So you push with your finger here and then it lights up or whatever. If you connect the 3 connections here. There is also no part number, no labels. I don't know which one is plus, minus, and signal. So maybe I will find it out while trying. I have 3 of them. If one gets broken, it's not so bad. What's that? Flux. Okay. Everyone can use a good soldering flux. Made in USA. Yeah, with a shiny 3D holographic sticker. So that must be good. MTech. Don't know. Never heard of that. Made in USA. At least not made in China, but that doesn't mean too much. Okay, case already has a crack here. So that could be inserted in some kind of push tool, whatever. May contain lead. What does that mean, may contain? It does contain lead or not? May contain lead. They are not sure what they're putting inside their products. Okay, another controller board with a display and with similar connections as the controller board here. Yeah, probably that belongs together. We have a PIC controller, most likely for the display and all that stuff. We have an USB interface, an analog to digital converter. Okay. Sparkysoft. Yeah, it's from the same manufacturer. So I think it should be possible to find out what exactly that is. So there are more connections for probably different kinds of displays that are not used at the moment. Unisolder 5.2, Unisolder 5.2. So these two belong together. Okay. And speaking of solder, we also have an original JBC solder handle, soldering iron handle, and we have a tip for that. Okay, okay, JBC. JBC, quite a good brand. Some say it comes next after Weller. Okay, nice soldering tool. Could make some brandings on my fingers. Yeah, it has that kind of connector that goes to the kit there. That looks brand new, never used. Nice. Certainly not a cheap device. Okay, let's put that back. Then we have a grey-white balance color card, Co UK. Okay, where is it? Here is it. So now you can adjust your screen, but only if my camera is adjusted properly. So I think it's not entirely white, but okay. That's probably a nice feature for color reference footage. Okay, what's that? Looks like a 7-segment display of some sort. It's a mechanical 7-segment display. That one looks a little bit bent. Are they all like that? Well, they are all on 0, not on 8. That's funny. No, I think that is supposed to look like that. Okay, mechanical. Ooh, coils. Wow. 1, 2, 3, 4, 5, 6, 7. Of course. I think I have to try that. Maybe I have 4 of them. That would be a wonderful clock again. Okay, what's that? It looks old. Precision condensator, that's the German word for a capacitor, and condensator. 1000 picofarad plus minus 0.3%. That's not bad. Manufacturing date 1970. Doesn't check. Maybe it's an oil-filled capacitor. Maybe it's a vacuum capacitor. Maybe that's the part number or the number of the family of capacitors. It has a ceramic tube here. Everything is soldered. So that could be a very precise capacitor. Thank you for that. And we get made in China. Okay, where else? All the good electronics come from China today. In the 1980s it came from Japan, as you know if you watched Back to the Future. Oh, it's a display, cool. Some sort of alphanumeric pixel LED display. I have such displays, but I never had a driver for it. I don't know if that board makes it any simpler, because I don't know how to connect that stuff. TFK, that's a Telefunken microcontroller, some sort of. Okay, display driver board thing with a button. Okay. Don't even know if that is power or not. Already a little bit difficult to use if you don't know what it is or how it works. What's that? Oh, it looks like a CD, but it's a grinding disc with Stevie Wonder on top. Probably that should remind you to wear safety goggles, because you don't want to get blind. Sorry, was a bad joke. Okay. Damn, that welding looks great. Yeah, after grinding it down with this disc. Then we have labels. Don't pull the cable. Yeah, that's always a good advice. Tektronix sticker. Okay, doesn't fit to my old stuff, but probably I can improve it a little bit with a new sticker. Updates, yes. Laser warning triangles. That's cool. I can stick them everywhere and everyone will be afraid of lasers. EADS, military airplanes. So that's calibration stickers. Okay. And last item, a transistor. It's a what? Let me see. It's a 2N3904. So what will Marco tell me with that? One transistor. Maybe it just fell into the box like that. Maybe there is a joke behind that, which I don't understand at the moment. And maybe he thought, well, let's just put a lost item inside. Okay, box is empty. Let's play with some of the parts. Well then, first thing to try out, mechanical 7-segment displays. They have 7 individual coils here. Each one has 2 connectors, so there is no common connector. Each one goes separately. And I found out that you need at least 10 volts to make them flip around. See that? And if you reverse polarity, you can make them white. And it stays like that. So you only need a short current pulse to change the display. On each segment. We put that so, and then you can flip them on or off. So let's play with that. That's a 1. And we make that a 2. Oop. 2. Then we have to turn on the center one, polarity reverse, to make it white. And we have to do that one. Yes, and we have 2. Maybe like that. Okay. And I have, of course, 2 more of them. So that would be an interesting project for a clock. I think I have to build a new clock here. Then we have that thing, RGB laser. Maybe I should put one of these stickers here to here. Yeah. So that makes it so much safer, so everyone can see. Oh, laser, dangerous. Okay, yes, lasers are dangerous, especially if you shoot them in your eyes. And sometimes it's not even necessary to shoot directly in your eyes. Even small reflections, if your laser is powerful enough, can be dangerous. I need something to pick up that laser light without too much reflection. So this black foam here should probably do. Maybe it starts smoking. I don't know how powerful that laser is. Oops, sorry. Yes. And we have some kind of... oh, it really starts smoking. We have white laser light. So all 3 lasers go together. And can you see it? Yeah, it smokes. Smoking hot. Okay, let's turn that off. Thank you. Yeah. Where's my camera? Here. There's it. A little black spot on the black foam. Alright, so power on. Smoke detector off. And I'm going to short circuit that blue laser thing. Let's see what's happened. Oh, what? Okay, blue has turned off. We still have green and red. Okay. So when we turn off one of the others, which is green, I should have a red laser. Okay, so what I notice is blue and green are circles, more horizontal circles, and the red one is more like a vertical beam pattern. Let's zoom in a little bit. Okay, so that's the red one. And if I add green, you see the green is much wider sideways. Let's turn the red off. So probably I have to turn these laser modules a little bit to make them equal. So we have now, what do we have? Green and blue. Yes, that's pretty nice. You more see blue than green, and that's blue alone. Yeah, okay, green, blue. So the last thing I could do today is to listen a little bit to Stevie Wonder. And, oh, it seems that doesn't fit in my CD player. It's a little bit too large. Too bad. I wondered how Stevie Wonder would sound here. Okay, thanks for watching.